Greetings, mathematicians. In this video, we are continuing to work with more exponent properties. In this video particular, we're starting with the power of a power rule. So this looks like you have a power here, and then it's raised to another power. And you'll see what's happening here in kind of this rule or this shortcut is that you keep the same base, and then you multiply the exponents. Similar to what we've done in the past, we'll look at why this works, and then we'll kind of use the rule as like a shortcut moving forward. So we'll start by expanding this first problem. So we'll look at x squared, and then we'll raise that to the 8th power. So remember that raising something to the 8th power means that you multiply it by itself 8 times. So x squared to the 8th means x squared times x squared times x squared, etc. You have 8 of them. So I've written out x squared times itself 8 times. And remember that x squared means x times x. So next I'm going to replace all of the x squareds with an x times x. And then last, I've got x times x times x times x. I've got a whole bunch of them, and if I count them all up, I've got 16 of them. So I've got x to the 16th. Now, rather than doing all of that work, that's kind of ridiculous, isn't it? What I can do is I can use that new shortcut that I've just learned where I keep the same base, so I keep the x, and I multiply the exponents. So I do the 2 times 8, and I get 16. So that's why the rule works, and then I can do a little bit less work moving forward, and I can kind of use this shortcut, this exponent rule. So looking at this second problem, I would keep the same base, so I would keep the y. I would multiply the exponents, so I would do the -3 times the -4, and then that would give me an exponent of a 12. Now here's another rule. This one's called the power of a product. So in the parentheses we have a product, we have a times b, and then that's being raised to a power. And our rule, or kind of our shortcut, says that both of the factors of that product end up being raised to that power. So they both end up getting that exponent. It's not quite like distributing, but it kind of reminds me of distributing. That's kind of how I remember this one. Again, we'll look at one of these problems kind of the long way, and we'll see how this works, and then we'll kind of use that shortcut moving forwards. So if we look at this first problem, we see that we've got something cubed. If we're cubing something, that means we're going to write it out 3 times. So just like that. And then using our associative properties and our commutative properties, we're going to rearrange all of this. So we're going to put all of the 4's together, all of the x's together, all of the y's together, all of the z's together. So again, we drop the parentheses, that's our associative property. We rearrange the order of things so that all of the like factors are next to each other. So put all the 4's next to each other, x's, y's, z's, etc. That's our commutative property. And now we're just going to individually look at this sort of like 4 mini problems. So 4 times 4 times 4, that's the 4 cubed. X cubed times x cubed times x cubed. Now we can use our product property for that, or we could expand it. So x cubed times x cubed times x cubed, that's 3x's plus another 3x's plus another 3x's. Y times y times y, z times z times z. And that gives us our answer there. If we had used kind of our shortcut at the beginning where we said it's not exactly distributing, but you can see it kind of gives the 3, that's the exponent, and it applies it to each factor. So the 4 got cubed, the x cubed got cubed, and when you do x cubed cubed, the power to the power product that we just did in the previous problem, that would do 3 times 3. That gives us the 9. The y got cubed and the z got cubed. So that lets us do a whole lot less work and just come up and straight to this last step without showing all of those in-between steps. Now for the next two, we'll just kind of skip all of that work again, and we'll go right to using this new shortcut that we've learned where we're applying that exponent to all 3 of these factors. So the 7 is going to get the -2 as the exponent, the x is going to get the -2 as the exponent, and the y to the negative 2 is going to get the negative 2 as the exponent. Now for these first two terms, again, we'll worry about the negative exponents in a later section. We don't really like those, and we do want to have another way to handle those, but we'll discuss that later. Over here, though, the y to the negative 2 to the negative 2, that's our power to a power, and the power to a power says we keep the same base and we multiply the exponents. So negative 2 times negative 2 is positive 4. So for now, we're going to stop here. We'll learn how to handle those negative exponents shortly. So we are going to work with these in just a bit. All right, for this last one, apply this negative 2 to all four terms. So the 6 goes to the negative 2, the x to the negative 6 gets raised to the negative 2, etc. Again, we'll deal with this negative exponent shortly. Zero times anything is 0. And we'll also deal with this 0 exponent in just a bit as well. One last comment here on this power of a product property. This is something that might help you solve a problem that we talked about earlier in the year. So we did this problem in one of our first sections in the course, and we kind of had to guess and check our way through it, which is fine. It's a good way to solve this problem. Something else we could do now, though, is we could use inverse operations here, and we could square both sides. And you could remember that squaring and square rooting are inverse operations, so they're going to undo each other. So the square and the square root on the left-hand side are going to undo each other, and they're going to leave you with the 10x on the left side. On the right side, because this is a product, 5 times the square root of 2, you're going to end up squaring both of them. That's basically this power of a product rule. You're going to square both things inside of there. So you're going to square the 5, and you're going to square the root 2. And you're going to square the 5, that's 25. You're going to square the root 2, that's 2. And then you would solve that for x like you usually would by dividing both sides by 10. And you can get x equals 5. And that eliminates some of the need for guessing and checking. This is just a bit of a side note here, but you can solve it this way. Now the one kind of caveat to this is that with square roots, sometimes it gives you something called extraneous solutions, and you always need to check these. So we talked about linear equations previously in this unit, and we said it's nice to check them. If you're working with square roots, you must check them. Sometimes you could do all of your work, not make any mistakes, and you get an extraneous solution, which means that even if you didn't make any errors, it just might not work. So you have to go back to the beginning, plug in your answer, and make sure that it ends up working. Now, I wouldn't put this together and get a 50. I would take this and then continue to do a prime factorization here, and then see if it really does simplify. So then you've got your groups of 5, and you do get a true statement. So it is a solution. All right, at this point we're going to pause, and we are going to stop this video before moving on, and there will be a couple more exponent rules in some following videos. So bye for now.